Hi everyone, it's Isaac with LangChain, and today we're going to go over how we can add structured output to our React agents. So to start off with, we are going to do a quick refresher on what a React agent is, and then we're going to explore how we can add structured output to it. So on the left-hand side of this diagram, you'll see what the architecture for a basic React agent is. And this is a very simple architecture. We're going to have one LLM in the middle, that agent node, and all that LLM is going to do is it's going to determine whether to call some tools or to respond to the user. And after it calls a tool, those tool responses will always be forwarded straight back to the LLM, who will then be called again to determine whether it needs to call more tools or whether it can just respond. If we want to structure our output, what we can do is we can add a respond node right before the LLM responds to the user. And what this respond node is going to do is it's going to take the output of that LLM and it's going to format it into the structured format that we wish to respond to our user with. It can be really helpful to respond in structured formats because this increases the reliability of our agent because we are having the same exact expected output every time we run it, and therefore we can use this agent in larger software systems since it's more deterministic and reliable, which is not always the case with LLMs. So now that we've got a quick refresh on what basic React agent is and how we're going to add structured output, let's go look at the two different ways that we can configure this respond node. The first way we can configure this respond node is actually by adding an extra tool to our agent LLM. And so you can see this blue box here, the response format tool. This is going to be a pydantic model that we pass to our LLM, and it's going to be able to call that as a tool, which is a very nice feature of LangChain. Once it's decided to call this tool, we're going to follow that blue arrow. We're going to format the response of that tool call, and then we're going to respond to the user. So the pros to this approach are that we only have to use one LLM, as you can see in the diagram, which is going to reduce latency and costs. However, when we're only using one LLM, it can be a little finicky. So the LLM could fail to call any of the tools, which is a problem because in this case the LLM doesn't directly interact with the user, it's only interacting with the tools. So if it fails to call any tools, we've run into an issue. Similarly, the LLM could call the response tool along with other tools, and that could be a problem. So these green box tools are intended to answer the user's question, while the response tool is intended to respond to the user. But what happens if the LLM chooses both a green box tool and the response tool? Well, we have to deal with that in our code somehow because most likely the LLM really wants to find out more information and is not looking to respond to the user yet, but there might be unique cases where it is trying to respond to the user or it isn't trying to use a tool at all and is just messing up. So we need to be sure that we're careful with all those cases, and these are some of the risks that can arise when using this option. The second option uses two LLMs. So as you can see, our original LLM that uses tools is going to only have those green box tools to it. So only those tools that provided information. And once it's determined that it's done calling tools, that it doesn't need any more tool calls, it's going to route to the response node. And that response node, instead of just formatting the tool call, like we saw in option 1, is actually going to call a second LLM. And this second LLM is going to be written such that it's forced to respond in our structured format. And this is a really nice feature of LLMs, that we can force them to respond in a specific format. So the pros to this version are that we are virtually guaranteed structured output because we're always going to reach the second LLM, barring some really strange loop with the LLM and tools. And since this second LLM is guaranteed to have the right response format, our overall graph is guaranteed to have the right response format, which is really nice. However, to guarantee this response format, we're going to have to introduce another LLM call, which is going to mean higher latency and higher costs. And in addition, the first LLM actually lacks the context of the response format. And what I mean by that is this first LLM here, maybe we ask it a question like, what's the weather? And the response format, say we want to respond with the wind speed. Perhaps that first LLM doesn't know that though, because we haven't provided it any context on the response format. So when the user says, what's the weather? It only looks up the temperature or the precipitation or whatever. And then it finishes querying that information. It thinks it's solved the question, and it goes to that second LLM. And now that second LLM is trying to format this response with the wind speed, but it doesn't find it anywhere. So that's one of the cons in this format. But now that we've ran through a quick overview of both of the formats, let's dive into some code and see how these work in the real world. All right, so now we are in our code repo for the first option, where we bind both the structured output and the tools to query the information to the same LLM. We only are going to have a single LLM in this graph. So we can start walking through the code. First, we're going to define our structured output class. In this case, it's going to be a pydantic model that mimics some sort of weather response. This is a very simple vanilla example, but you could make this as complicated as you want. Next, we're going to define the input, output, and the state to our graph. So the input is just going to be the messages state, and that means it's just going to be a list of messages. Our output is just going to be our final response, which is going to be of type weather response, that structured output that we had above. And then our overall state is going to contain both the input and the output state. So it's both going to keep track of a list of messages by subclassing from messages state, and then it's also going to keep track of the final response. Next, we can define our tools and our model. So we're going to be using the Python tool decorator here to define the getWeather tool. And the getWeather tool can be written as a Python function with the tool decorator right above, which is really cool and makes turning any Python function into a tool super simple. And a really cool thing here, or at least something I think is cool, is that we can bind both this getWeather and this weather response to our model. And the reason I think this is cool is because getWeather was defined as a Python function that we added a decorator to, and weather response was defined as a pydantic base model. But we can pass both of those in, and under the hood, LangChain is going to deal with converting those to the proper format for the LLM to interact with, which is really nice. So now we have our single LLM, which both has the getWeather tool and the weather response tool. So it should not only be able to solve the user's query, but it should also be able to respond to the user in the correct format. So next we can define our graph nodes, and we're going to have two nodes. We're going to have our call model node, which is going to actually call this model, and then we're going to have our respond node. So our respond node is just going to take the last tool call that was made from our model, and that last tool call is going to be the weather response tool call. So once we're at the respond node, that means the weather response tool got called, and we're going to take the arguments from that tool call, and we're just going to pass those to our weather response object, and then we will return that as our final response. Next, we can define our routing function, which is going to inform our graph what step it should take next based on the output of the LLM. So if the LLM outputs a single tool call, and that tool call is the weather response tool call, we're going to respond to the user, and otherwise we are going to go use our other tools. So in this case, the getWeather tools, but any tools that are helping us answer the question and not respond to the user. And note that we make that check for the tool call length being 1, because we want to ensure that the LLM is only responding to the user. It doesn't have any more information to get, and that is going to be the case that we respond. So now that we've done all of that, we can define our graph structure, which is fairly simple. We're going to be defining a state graph with our aforementioned agent state, agent input, and agent output. We're going to add our three nodes, the agent node, the tools node, and the respond node. We're going to set our entry point as agent. The graph is going to start by calling the LLM. And then we're going to add our conditional edges from the LLM to the should continue function, which we just defined above. And lastly, we'll add an edge from the tools to the agent. So as soon as we call tools, we're going to get that response right back to the LLM. And then we're going to add an edge from the respond node to the end of the graph. Once we hit the respond node, we are done. Lastly, we'll compile this graph so that we can use it in LangGraph Studio. So now that we're done with all that, let's head over to the studio and see how this works in action. All right, now we're in the LangGraph Studio, and on the left-hand side, you can see our graph visualization very nicely, and we can input our question to our graph. So we're going to ask it, what is the weather in SF? And we're going to see the graph running both visually on the left-hand side, and on the right-hand side, we're going to get a stream of the output. So perfect. We see that the AI first calls the getWeather tool, which then returns its response, and then it calls the weather response tool, which routes it to the respond node, and then our final response is exactly what we are hoping for, this structured weather response object with the wind direction, the temperature, and the wind speed. And now we can actually open this run in LangSmith and verify that everything worked as expected. So as it loads, we can see that our rendered output was exactly what we expected, which is great. So the output from the studio matches the output in LangSmith. And then on the left-hand side, we can actually see the exact trace of what went on. So we can see the nodes that got called. So it called the agent node, the tools node, the agent node, and then the respond node, which is the flow that we were hoping to receive. And then if you wanted to further debug what's going on, you could dive into each of these LLM calls, looking at the input and the output. We're not going to run through all of that right now, but LangSmith is a great place to do all of your debugging, and it couples really nicely with the front-end UI that you get from LangGraph Studio. So now that we've taken a look at option 1, let's go explore the second option where we use 2 different LLMs to structure our output. Alright, so now I'm in the code for the second option where we're going to have 2 LLMs. I'm going to skip over defining the weather response and our input, output, and graph state because those are the exact same as they were defined in option 1, so you can go back in the video to look at those if you want. The first difference we're going to have between these 2 options is that we're defining 2 models here. And so the first model is just going to have the getWeather tool binded to it. So as you can see, our tools definition is now a list of length 1, and it just contains the getWeather tool. And then we're going to have a second model called the model with structured output. And this model is going to use the .withStructuredOutput method from LangChain, and we're going to pass the weather response. And now this model is going to be guaranteed to always output a response in the format of the weather response pydantic model. So now we can define our graph nodes. Again, our call model node is basically identical to the first option, except this time we're not using the model with the response format bounded as well. It only has the getWeather tool. We're going to invoke that and return whatever the result of that invocation is. And now our respond node is a little more complicated. So instead of just passing the output of a tool call, we actually need to structure the output somehow. So we're going to use that model with structured output, and we're going to invoke it on the content of the second to last message. So that second to last message is going to be the prior tool message in the conversation. So if you remember the flow, what's going to happen is it's going to go from agent to tool, back to agent, and then to respond. So once it's at respond, that means that 2 steps ago, it was at the tool node. And so we can take that second to last message, grab the content from that tool message. So that's the output of the tool. What did the getWeather tool respond with? And then we just want to structure that response. We have to make one little trick here by converting that tool message into a human message, because you can't invoke an LLM with just the tool message. The LLM is going to be expected to be invoked with a human message. Then we can define our routing function, which is fairly similar to option 1, but in this case the check is a little simpler. If there are no tool calls, that means we're going to go to the with structured output node, and if there is a tool call, we're going to use that tool. And our graph definition is the exact same as option 1, so I'm going to skip over that, and instead I'm going to head back to LangGraph Studio to show you how this option looks on the front end. Alright, now we are in LangGraph Studio, and we can see again our graph nicely visualized on the left hand side, and we can input a question to it, and we're going to ask it this time, what is the weather in New York? And once we click submit, we are going to see our graph running. On the left hand side we can see the visualization of that, and on the right hand side we can see the output getting streamed. So we're going to see our AI is first going to call the getWeather tool as we expected, and then the second response it has, there's no tool calls in this response. And so that's going to route us to the respond node, which then calls our model with structured output. And as we can see here, it returns the output in the exact format that we would expect. So we can actually open this run in LangSmith to verify that everything worked as expected, and perfect. On the left hand side, again, we see the exact sequence of nodes that we saw in the studio: agent, tools, agent, respond, which is exactly what we expected. And then we can verify that that output is in the proper format, which it is in this case. And then if you wanted to do more debugging, you could dive deeper into each of these traces and see what's going on. That wraps it up for this video on structuring the output of React agents. I hope you learned a little bit, and I hope that you can use what you've learned in this video to build some cool projects with LangGraph. Have a great rest of your day.